Okay guys, today we are going to be talking about confidence intervals for means, and I have an example for you. So let's say Eric Caldwell is jumping hurdles for the track team, and he wants to find the time it takes for him to clear 3 hurdles. Okay? To do this, he can create a confidence interval for the mean time. A confidence interval will give him a range that captures the true mean time it takes for him to do this. So, first things first, here's the equation. We want the sample mean plus or minus the t star times the sample standard deviation over the square root of n. Are there any questions? Yes, Sarah.
Why do you use a t-star and not a z-star?
We use a t-star when we don't know the population standard deviation. If we did know sigma, this variable, which is the population standard deviation, we would use this equation. However, we are not given that, so we want to use t-star. Okay, so to find t, we need to know how confident we're going to be. The most commonly used confidences are 90%, 95%, and 99%. The confidence is described by this variable. For the purposes of our study, let's use the 95% confidence. Because the more confident you are, the wider the interval, meaning the less precise. So let's just pick the middle. Okay, so now that we have our confidence interval of 95%, the next thing we need are the degrees of freedom. We use degrees of freedom only for the t intervals. To find that, we just need n minus 1, where n is the number of samples that we've taken. We want to make sure that we choose a big enough sample, or a big enough n, to reduce the variability in our interval. So, we're going to choose, or take, 20 samples of Eric jumping the hurdles. Subtract 1, so our degrees of freedom is 19. Okay, so now I need a volunteer to do the problem with Eric jumping the hurdles. Any volunteers? Sarah, thanks! Okay, Eric, so now that we have our confidence interval, what does that mean?
Well, this means that we are 95% confident that my true mean time falls within this range.
Very good.